After comprehensively improving my methodology for measuring brain volume from MRI data, I remeasured the samples shown in my previous EQ comparison video and joined new samples. Although I experimented dealing with substructures, such as gray matter and white matter, I found that these approaches only introduced more errors. Therefore, I finally measured only the whole brain volume. Here are the final statistical results. Overall, there is little difference from my previous findings. The Caucasian sample consists of white Americans, white British, and a few Europeans. The Chinese and Indo-Chinese sample consists of Chinese nationals and British Chinese. There is one thing that needs noting is that my own results were not included in the table, to ensure that the results for the Chinese and Indo-Chinese category fit a randomly selected population more. As shown in the figure, Caucasians have a lower EQ than Japanese and Koreans, but a comparable EQ to Chinese, while their absolute brain volume is significantly larger than that of Chinese. One might infer that Caucasians are likely to differ from Japanese and Koreans in mental capacity, but there is insufficient evidence from EQ and brain volume alone to conclude that they are less intelligent than Chinese. Compared with Japanese and Koreans, the lower EQs observed among Europeans and Chinese are predictable. Many of them look like just lighter-skinned Negroid or albino Dravida. In my previous videos, I have already demonstrated how I precisely measured brain volume. Here, I will further explain how I estimated human body weight. It is obvious that using raw body weight to calculate EQ is unfair to fat and muscle people. Therefore, I used the U.S. Army anthropometric datasets Answer 1 and Answer 2 to perform regression analysis between body weight and various anthropometric measurements, allowing me to fairly compare human body size. First, I selected cases aged 18 to 34 years. Then I excluded cases with a body roundness index greater than or equal to 3. Next, I excluded women with a waist-to-hip ratio of 0.8 or higher and men with a waist-to-hip ratio of 0.9 or higher. After that, I performed a regression analysis of neck circumference against stature and removed cases whose residual neck circumference fell outside the median plus or minus 1 interquartile range. I then conducted a regression analysis of body weight using biochromial breadth, hip breadth, and stature as body size predictors. The predicted body size was subsequently regressed against biceps circumference, forearm circumference, thigh circumference, and calf circumference. Then cases whose residual values fell outside the median plus or minus 1.5 interquartile ranges were excluded. This process ultimately produced the formulae shown in the figure. Body dimensions are recorded to the nearest centimeters, and calculation results are recorded to the nearest hectograms. The first formula is intended for populations with a BRI below 3. The second formula is designed for cases in which factors such as obesity make hip breadth difficult to measure accurately, and datasets in which only stature is available, as in this video. I already accurately measured my own biochromial breadth and hip breadth using a caliper with a 50 centimeter range, and my stature was also measured accurately during a hospital physical examination few years ago using a standard height and weight scale. When EQ is calculated using body weight estimated from stature alone, 2 men and 6 women among nearly 300 healthy young adults have slightly higher EQs than mine. However, when my EQ is calculated using body weight estimated from stature, biochromial breadth, and hip breadth, only 1 Japanese woman and 1 Korean woman have slightly higher EQs than mine, assuming that if these people have body breadth measurements, they are not below the average. Considering that the encephalization quotient is currently the only biological index on which humans are clearly superior to all other species, women have higher EQs than men suggests 2 possibilities. First, women may indeed be more intelligent than men, but have different interests. Second, the EQ differences may be explained by sex-based differences in brain cell density. In the only reliable comparative study of men and women's brain cell density, neocortical glial cell numbers in human brains, men were found to have 1.23 times as many neurons and 1.39 times as many glial cells as women. Therefore, after correcting for brain cell density, my EQ would be ranked at the top among nearly 300 healthy young adults, once again demonstrating my exceptional intelligence.